doing math with RHB. We're looking at lesson 32, which is reducing fractions to lowest terms. That is the last, or this is the last lesson before we start doing add and subtract. These are all the preliminary things that you need to be able to do before you can actually add, subtract, multiply, and divide fractions. So I'm going to turn on the overhead. You're going to get that bright flash of light. So when you're reducing fractions to lowest terms, the protocol is the same as it was for some of the other series in the fractions. Whatever's done to the numerator, you have to do the same thing to the denominator. So to reduce fractions to lowest terms, you want to reduce it by taking the largest number that'll divide evenly into both the top and the bottom, so the numerator and the denominator, and then once you divide those out, you'll have a reduced fraction. If you don't choose the highest number, you may have to reduce again. And why do they reduce fractions? They reduce fractions so that you're dealing with the very basic fraction and not some monstrous number. It's way easier to think of 3/4 than it would be to think of something like 175 over 200. You know, like you're better off with 3/4. At least people have a better mental picture of that. It's much easier to deal with. So, looking at our examples, I'm going to move this up. We have example A, 12 over 16. We need the largest number that will divide into the numerator and denominator. It has to be the same number. So this is where you get that fraction equivalent of 1 again. So we're going to divide by 4. It's the largest number that'll go into top and bottom evenly. So if I divide 12 divided by 4, I will end up with 3. If I have 16 divided by 4, I will end up with 4. The only number that will divide evenly into 3 and 4 is 1. So there's no point in doing that, so you end up with 3/4 as the reduced fraction. We look at example B. 2/3 equals x over 9. What is x worth? Here's an x with my tail. So we have a couple of different ways we can solve this. All right. What did we do to 3? To get 9, we multiplied by 3. So therefore, whatever I've done to the denominator, I have to do the same to the numerator. So I will multiply this by 3. And that will give me 6. So x is equal to 6. So x over 21, this is our third example. Make sure you can see that on the screen. Yes. X over 21 equals 2 over 7. What does x equal? Alright, so I have a larger number here instead of the larger number over here, and the 7's not very good. There. So, what did we do to 7 to get 21? We multiplied by 3. So 7 times 3 is going to be 21. Whatever I've done to the bottom, I have to do the same to the top. So if I've multiplied 7 times 3 to get 21, I have to multiply 2 times 3. And that will give me 6. So x equals 6. So there's several different ways they can present questions. When we're adding, subtracting, multiplying, dividing, we're going to end up with answers that are large sometimes, and that's where you need to reduce the fractions to lowest terms, so that you're working with numbers like 3/4 instead of 12/16 or 6/21. Right? It's very hard to get a mental picture of what that even is. Whereas 3/4, most people can picture 3/4 of a dollar. makes it simpler. Next lesson will be addition of fractions.